A function is odd if f of minus x equals minus f of x. And a function is even if f of minus x is equal to f of x. Here is a graph of the cosine function y equals cos x. Now if we take this value here, cos of minus 60 degrees equals, well, we can read it off the diagram, there it is there, it's 1/2. And lo and behold, it's exactly the same value as cos of 60 degrees. So here we have an instance of an even function where cos of negative x equals cos of x. So the cosine function is an even function. And here is the graph of y equals sine x. Now if we look at the diagram again, we've got, well, let's take this value here. So sine of minus 30 degrees equals minus 1/2. We know that sine of 30 degrees equals 1/2. What we can say then is that sine of minus 30 degrees equals minus the sine of 30 degrees, which is to say that the sine function is an odd function. Now, look at the diagram again. We can see that if a function is odd, then it has 180 degree rotational symmetry about the origin. And if you think about the cosine function, it has line symmetry about the y-axis. Here's an example. Y equals x cubed sine of x. And we want to try and figure out whether this is an odd function or an even function. So what we do is we replace x with minus x. So y of minus x equals minus x cubed times sine of minus x. Now, if we cube a negative number, because the power is odd, we'll end up with a negative answer. Consider minus 2. Minus 2 cubed is, well, minus 2 cubed if the minus is in the bracket. Minus 2 cubed is minus 8. Minus x all cubed is minus x cubed. And we've just learned that the sine function is an odd function, so sine of minus x is minus the sine of x. The next thing is to realise that the two negatives cancel, so we end up with x cubed sine of x. Now x cubed sine of x is exactly what we started with. So we've replaced x with minus x, and we end up back where we started, which is to say y of minus x equals y of x. So this particular function is an even function. Here's a second example. We've got a polynomial, f of x equals x plus x cubed plus x to the power of 5. So we want to investigate this function. We'll replace x with minus x. Now, because the powers of these terms are all odd numbers, it means that each of the terms is negative. So minus x to the power of 1 is minus x. We've just dealt with it, minus x to the power of 3, that's minus x cubed. And minus x to the power of 5 is, or minus x all to the power of 5 is minus x to the power of 5. Now, what we can do here is take out a negative 1 as a common factor. and that gives us minus f of x. And if f of minus x equals minus f of x, then the function is odd. Example 3, f of x equals x squared plus tan x. So what we want to do is to replace x with minus x. So f of minus x then is minus x all squared. Now, what we could maybe do is write tan x as sine x over cos x. And remember, we're replacing x with minus x. So minus x all squared is x squared. Now we know that sine of minus x is minus sine of x. And we know that cos of minus x is cos of x. So it would appear that I'm going to change sine over cos back to tan. Now, see, these are original. So these are not the same. So it's not an even function. It is not an even function. If we were to multiply this by minus 1, we would get minus x squared minus tan x. Now the minus tan x is fine, but we don't have a minus here. So what that means is that the function is not odd. And what we conclude then is that the function is neither odd nor even. Example 4, now here's a past paper question. We are told that the function is an odd function. Now, consider the sine function. It said that the sine function has 180 degree rotational symmetry about the origin, and that's an odd function. So what we want to do is to complete this diagram to show 180 degree rotational symmetry about the origin. So what we're going to have to do first is to perhaps draw in another asymptote to match this one here. So probably want something like that, and this is going to be at 3. And then what we're going to do is to have a curve that looks a bit like that. That would complete the diagram to show rotational symmetry, half-turn rotational symmetry, or 180 degree rotational symmetry about the origin. And this point here would be, so we've included the asymptote, and that point would have coordinates 1, 2, and we might want to put in the equation. We know that this one is y equals 1/2 x minus 3, so this one will be y equals 1/2 of x plus 3.